You're listening to Lab Out Loud, Science for the Classroom. I'm your co-host, Dale Basler.
And I'm Brian Bartell. Many of you might remember our guest today. She's Marcia Bjornerud, and she was on the show back in 2018 when she had a new book out called Timefulness. The other thing about Marcia that many of you might remember is that she's my neighbor. And so this is one podcast where I may have scheduled it in my front yard because Marcia walks by my house quite a bit. But Marcia is back because she has a new book out called Turning to Stone.
The main message of the book is that actually the stone-faced Earth is not just an inert rock. It's a very dynamic, creative, possibly sentient thing. And the more we learn about the solid Earth, the more we realize what a strange, almost cyborgic planet this is.
It's interesting because, you mentioned that this is turning to stone that way. I kind of took that as transformation, it maybe harkens back to like the Medusa kind of idea of like turning to stone, but a transformation in and of itself, like going through a process. And you did write this with your own like path in life as a human being, right?
Right. So the title does sort of also mean that we can turn or refer to stone for insight. And yes, I use my own small human story as the sort of scaffolding for much larger planetary stories. I was very reluctant to write anything like a memoir or autobiography. An editor suggested that to me some years ago, and I kind of rejected the idea initially. But I gradually realized that I could use my own story of coming into the science of geology as, well, an outsider to science completely, as a young girl growing up in a time less enlightened than today, not feeling welcome in science classrooms. And then also, as somebody who came into the field at a really an inflection point in the history of the geosciences. I don't know that people realize that we're in a golden age of geoscience right now. We finally have the tools, the data collecting capability, the computational capacity to really understand Earth in ways that we never have before. And in my experience, the public perception of the geosciences lags far behind what we actually are doing in the geosciences today.
Right now being what, the last 5 years, 10 years?
I think the last 20 years.
20 years? Oh, okay. Yeah.
Yeah. And sadly, that trickles down to the way we teach the geosciences in schools too. The lack of representation of rigorous geoscience in most school curricula, and there are exceptions. I'm not saying that's true everywhere, but sadly, very few middle and high schools have truly rigorous modern geoscience represented in their curricula, and that's just an artifact of the relatively late development of the geosciences compared with, say, physics, chemistry, and even biology.
So do you see like a renaissance coming that we might get there?
I hope so. I think that people are becoming aware of the fact that widespread geological illiteracy is really at the root of many environmental problems. But as you know, as people deeply involved in public education, changing school curricula is a challenging process. And, convincing school districts to introduce radically new ways of teaching and hiring people to do that takes a lot of time.
Right. And and obviously there's political things attached to it as well. Even something as much as a teacher shortage, because even if there was the will to get a new curricula in place, there's not necessarily people who are equipped to teach it that way. And in Dale and I have seen this within our own lifetime as an educator, a science educator, where we saw elements of geosciences kind of shoved into the physical science curriculum, at least in Wisconsin. And so we saw, for instance, discussions of plate tectonics had to kind of sit amongst physical science concepts, and it, instead of having its own place at the table.
Yeah, and that's fine. It's good wherever students are encountering this. It's a good thing. But it really strikes me as tragic that the one science that every Earthling should be exposed to is earth science. It has such explanatory power. It explains how the world came to be the way it is. It's relevant to resources ranging from groundwater and surface water to oil, gas, minerals, and then of course climate. If the average citizen really did understand the magnitude of what we are doing to the climate system and had understood that 50 years ago, I have to think that we would have held oil companies accountable, and we would have expected our legislators to take action far, far, far earlier. And so now we're in a situation where, because of widespread ignorance of the way the planet works, things have become politicized almost beyond repair. So it has real tragic consequences.
I would imagine there's teachers listening that say, well, we do teach, we are teaching this, particularly about, if I think about earth science at the elementary level, you're getting your rock cycle, you're getting some of the things about climate. Would you argue that is just not enough? It's just a passing, flipping the book in front of their eyes, like here are some pictures of it is.
Well, it's the beginning. It's the essential beginning. But imagine if we never took students in chemistry beyond, the elementary school level, the basic vocabulary of atoms and molecules, and didn't return at increasing levels of sophistication to these concepts. This is the status. Again, there are wonderful exceptions in some school districts that have well-established earth science and geoscience. But in my experience with my own kids and with our students coming into the college level, that's the exception rather than the rule.
Mm-hmm. So that the idea that earth science is essentially only an elective, something that a kid could choose after middle school, essentially, yes. High school, you could avoid earth science in many, many school districts. In high school, yeah, you're going to get such a weak.
In many schools, it's sort of seen as the science for the kids who are not college bound.
Always. It's been like that since I started. Yeah, I mean, my first year, I had earth science. I had like your general 9th grade science and then one earth science. And I know it was introduced that way to me too. Like, these kids are not doing X, Y, and Z, so don't sweat it too much. And, at that time, guidance counselors that were planning, the student's schedule sometimes were like, well, let's pop you into this class for credit and things like that. So.
And it's great that the kids who are not college bound are getting that, but it also sends the message that earth science is kind of not interesting or important. And there's a group of people working with the American Geophysical Union, which is one of the major professional organizations of geoscientists, to introduce an AP geosciences course to send the message. This is an effort to make it sort of an attractive thing to more ambitious students, and hope that trickles down into the curriculum and sends the message. This is a rigorous discipline that we need good minds to solve some of the problems that we've created for ourselves on this planet. So, yeah, again, I'm not disparaging what the hardy earth science teachers are doing out there in many schools. But it's always kind of a second priority. And again, that's to the detriment of humankind, I would argue.
Sure.
An AP Geosciences class, though, that, like, think about all the field trips that you could mandate. That'd be amazing, you know.
Well, that is a problem with teaching earth science, I feel, because you have so much abstraction. If you can't go even do a little roadside geology. When I think about, I went to college for geology. When I did field camp, when I had actual experiences at places, that's where I have moments now where I still experience geology. And I have that kind of like that hit in the chest of just like, oh, like for me, it was always like, look at the time, look at the story here and this vista in front of us.
I have a lot of thoughts there. I mean, I absolutely agree. And I prefer, if I can, to be teaching outdoors on the outcrop, where people are engaging with all of their senses with nature, unfiltered.
Mm-hmm.
But of course, we came through COVID and we learned a lot of ways of trying to foster that geological imagination without being able to have some of those experiences. So first of all, let me say that in 30 some years of teaching geoscience at the college level, I've realized that more than anything, more than rock and mineral identification or even, just acquiring some of the basic concepts, geology is an act of the imagination. Thinking geologically requires great capacity for envisioning things. And that habit of mind is best developed, I think, in nature, if you can do it. But there are so many, wonderful visualization tools, simulations out there these days that we can use if we're not able to get students out on site somewhere.
Yeah, true.
I think we're in, again, a golden age for geoscience teaching because of that. There are just so many really wonderful kind of glimpses of Earth through time, simulations of tectonics or climate change that we can tap into that will help students develop those cognitive habits of mind of zooming in and out of space and time, which to me, that's really the hardest thing about thinking geologically is that.
And I would think my argument about it being too abstract doesn't hold any water because chemistry, hello. The fact that you can learn about an atom and a molecule and polymers and things that you actually can't see to the level of the model that's in front of you. So that would be the counterpoint to that.
Do you see your students reflecting in those ideas as they're coming into you? Has that changed over the 20 years? Do you see these glimpses of students coming in and they get that a little bit more, or they get it less, or they have a passion for the earth in different ways? Has that changed?
What's remained the same is that we have very few students walking in the door knowing they want to study geology, or now geoscience is more an umbrella term that many departments, including ours, are using. And that's because it's not represented in high school curricula. So that's been a through line, and we kind of find geology, geoscience majors through the intro class, where people often take it because they're avoiding taking a lab science in physics or chemistry. And they think the geosciences will be easier. And then they realize, oh my gosh, this is my life's passion. So that's always that's the way we find our majors. I think some things have changed. Students these days have grown up with the dark cloud of climate change over their heads. It's not news to them. And if anything, we need to find ways to keep them from despair.
Yeah.
To empower them with their knowledge of how the planet works, to think of, okay, here's the reality, but what do we do about it? Whereas 20 years ago, we were still kind of flogging people over the head with the idea that the climate is changing due to human activity. I think another thing that I've noticed that's very specific to earth science, geoscience majors is people don't have the capacity to just read maps much anymore. They're so used to having ready maps on their phones that will reorient, depending on which way they're looking. They have a lot of trouble kind of internalizing geography in their own heads. And when I say that, I feel kind of old-fashioned, but I do think that there are certain habits of mind that people just haven't developed the muscle for. Because they haven't really been challenged to do that. And that can get in the way of some of the higher level visualizations that we would like students to do. If you've never really kind of tried to figure out which way is north on your own, or had a mental map of a place, it's hard then to overlay that place over time, or imagine different geographies of the world. So yeah, I think technologies help us, but they can also hurt us by making us a little bit lazy and not developing that capacity for imagination that is really important.
I remember having conversations before on our show about the despair comment that you made, like trying to steer away from making the content area too doomsday, basically. So everything in your lessons, like then try to focus on an action item, like end on a place of action, end on a place of advocacy. How do you? I'm curious to know if you have thoughts about that, because that's certainly come up in our classes. Just that, anything discussing climate change and those kinds of things, where you can hit those.
Yeah.
That kind of mentality, everything's going to burn and flood or something like that.
Yeah, and that leaves students just paralyzed. There's no.
Yeah, they just disengage.
Yeah. So, I mean, it's partly that here are our values, in a sense, as earth scientists. We know this is how the earth works. And so let's stay true to those things. We know that when the carbon cycle gets out of whack, bad things can happen. So let's find ways to kind of live within our biogeochemical rights as earthlings. I think just kind of helping students articulate what can I do in my own personal life that will allow me to feel I'm not breaking natural law in some way. And then we in many classes these days, we look in quite a bit of detail at proposals for carbon sequestration, for example. The idea of mimicking Earth's natural long-term carbon sequestration system, which is weathering of silicate rocks, which are most rocks, like igneous rocks, by carbon dioxide in the atmosphere, dissolves those rocks through rainwater, takes their constituents to the sea, and precipitating limestone is the end result. And limestone is really where more than 99% of all the CO2 that's ever been exhaled by volcanoes resides now. It's Earth's way of putting away atmospheric carbon dioxide over time. So some people are proposing what they call enhanced rock weathering. It's a not too risky way of potentially mimicking that process by putting crushed rocks like basalt, if you've got a nearby source for them, on agricultural fields. And it actually is kind of a fertilizer. These rocks tend to have pretty high levels of potassium, for example. So it's not going to damage any soils or crops. And fingers crossed, maybe that natural process of silicate weathering will be enhanced a little bit and will help put away some of the CO2 we've spewed out. Now, the question of how effective that would be and the balance of transporting crushed rock,
yeah,
energy output, those are good sorts of.
It seems to be the more subtle geoengineering idea that I've heard. Like some are just like
some are scary.
No.
Yeah, I go down that road. Sulfate aerosol injection.
Yeah.
But others where they are really geomimicry. Those are great things for students to kind of roll up their sleeves. Let's take a look at this. How realistic is this? I mean, people are selling carbon credits and things based on these things, and it's worth delving into. What are the risks? What are the costs? What's the net CO2, kind of optimally, that we could, CO2 sequestration that we could achieve. So I think that kind of thing where students are learning about the Earth system and then applying it in real time to things that are going on, is one way of getting people engaged without, just leaving them despondent.
Yeah, for sure. I want to come back to something you said right at the beginning that caught my ear too. You said, I believe it was almost sentient about the Earth. I want to know more about that. Are you talking to the rocks? Are they talking to you? We'll be right back.
Okay, first of all, I'm a structural geologist, so I study how mountains grow, the plates move. And so surely in my field, we routinely talk about rocks moving, rocks flowing in the solid state. They're definitely animate. They're moving around. I also study metamorphic rocks that have made amazing journeys into the deep crust and have come back to the surface. So the planet is weirdly roiling in motion and all the time. So animate for sure, in the sense of moving around. Mm-hmm. Sentient, I know that's maybe treading toward poetry, but what I mean by that is that the Earth is not an inert, insensate rock. It's noticing things we're doing. The climate change is affecting even the solid Earth as glaciers melt and permafrost loosens its grip. Avalanches are happening. The Earth is noticing. So that's the way I'm using that word, is that the part of our problem in the West is assuming that the Earth is
not responding,
unresponsive.
Okay. Yeah, and also all in the air too, as opposed to you're right. Some of the solid aspects of that's kind of interesting.
And I mean, even we cause earthquakes. Solid Earth responds to deep injection of waste fluids from fracking or other activities. And so, this attitude that somehow Earth is kind of slow on the uptake is wrong. And that's part of what I'm trying to convey in all of my books, but especially this last book, where I start with sort of simple rocks and in my youth, and then take the reader to more and more nuanced, complex rock texts, I guess.
So in many ways, and it kind of like you're coming full circle here, your book, when you were writing it, you put a lot of your personal life into the book, but you're also suggesting that there's a personality to the Earth in a sense, or at least, we'll go with personality.
Yeah. I mean, I do have relationships with rocks that I've studied in detail. It might be unrequited love. I'm okay with that. But, I have spent a lot of my waking hours as an adult in deep conversation in my head with rocks, trying to understand what do they signify. I guess more than anything, I sort of see myself as a translator, rock to English. And it's there's a kind of intimacy there when you really engage in the logic of something else.
You know what this reminds me of, and I hope this doesn't upset you, but it reminds me of when someone has seen a TV show that they love and no one else is watching it, and they're like, no, but there's this one, like the rocks. Almost to me, it sounds like you're describing a cast of characters. Your metamorphic or the old wise ones. They've been through a lot. You have this cast of characters, and you're basically like, you have to watch this. You're surrounded by people who are missing this show, and you're desperately worried about it getting canceled.
Well, it's not going to get canceled because
we're going to get canceled, right? Yeah.
So I mean, okay.
We're not talking about the despair, right, Dale? We'll
lose our viewers.
No cancellation.
Mm-hmm.
I mean, I am a bit of a geo-evangelist. I realize that, but to me, it's like this is our story as Earthlings. So I think it's it is relevant, and I think it's transformative if people really understood the strangeness and wonder of this planet, it would be transformative. Maybe that's naive of me, but I feel that in my bones.
No, I don't think so. In fact, as you're kind of mentioning how you wrote the book and that you put a lot more of your personal life into it, do you see yourself doing that in your own instruction when you're teaching in the classroom? Have you allowed yourself to be more personal as a way to teach?
I think over time I have. I think when I first started out, I was, particularly as a young woman in a male-dominated field, I was very careful to hold myself professionally at a distance from students. But over time, as I've become more comfortable in my role as professor, I think I've opened up a lot. And I mean, as you know, both of you, field experiences are an equalizing thing.
Mm-hmm. Yeah.
You run into all kinds of human problems when you're camping with students and whatever. So, it's just by the very nature of my job. I think I do engage really very personally with students. We can't help it. And it's a good thing. We really do develop lifelong connections because of those very human misadventure.
So you're kind of like an Earth mother and Den mother on these field trips,
I guess
field
so.
experiences. Yeah.
Exactly. Yeah. But in the book, what I also try to convey is how I came into the field and how initially it was really, an intellectual thing. I frankly kind of loved the vocabulary of geology because I had come in, like many of our own students, I took an intro geo course in college, mainly to check the box on the lab requirement. I thought of myself as more of a humanities person. And I loved the idiosyncratic vocabulary of geology, which is kind of off-putting to a lot of people. But I just thought oh, this is wonderful. All these weird rock, mineral, landform names borrowed from languages all over the world.
Ah, okay.
And then I realized that, then those things themselves were texts, that geology was the etymology of everything. And what started as kind of, an intellectual, and it still is an intellectual thrill to me, it just gradually became grafted onto my own personal worldview, I guess. And that's what I'm trying to convey in the book, that yes, I am a scientist and I can see this through a scientific lens, but I think there is something even deeper. Geology is a weird mashup of very practical and philosophical questions. It's about deep origins and existential things, as well as how do we find, copper, that sort of thing. So you're not paying attention if you don't notice that there's some really profound questions that geology touches on.
As you call yourself a geo-evangelist, and you've been doing writing and have gotten a much, larger national and worldwide audience there, what have you learned about yourself as a science communicator?
Well, I don't know if I've learned about myself, but I have learned that there's a huge
Or
appetite.
about science communication. How's that?
Yeah, I've learned that there's a huge appetite among people of all kinds of different backgrounds to understand the Earth. People write to me. It's kind of, I try to write back. It's almost overwhelming, the amount of email I get. And often nice handwritten notes too, that are really heartfelt. I mean, they're not just can you identify this rock for me? Sometimes.
Do you get those?
I get those. And I'm
nice.
happy to do that too. But I mean, often people are really writing.
That's a whole book in itself, right?
Yeah. So that's what I've learned mainly is that, there's this huge unmet need that people want the bigger framework. They don't, rock and mineral identification is important. That's kind of the vocabulary of geology, but you need to understand the grammar and the syntax and the history and the culture to really, get the whole picture. And we're not providing that in our schools. And there haven't been too many books that try to give that whole panoramic view. There's a lot of dinosaurs. Dinosaurs are like the attention-hogging celebrities of the paleontological world.
Oh, so now we had
the Kardashians of
exactly.
Our last podcast, or a recent podcast we had, we talked a lot about pseudoscience, and this was in the mental health industry and the wellness industry. Are there geology pseudoscientists? And
Oh yeah, I mean the most visible ones are young Earth creationists. I was just looking the other day. I was trying to grab a graphic on uranium, lead, zircon dating. Lazily didn't want to create one of my own. And one of the first hits I got was from the Institute for Creation Research. I mean, people are going deep. They're reading papers in the scientific literature and then trying to debunk them, quote unquote.
Mm-hmm.
So that's a perennial thing, that people are actually fighting against the idea that the Earth is 4.5 billion years old and still trying to promulgate a literal biblical version of the Earth's history. And there are other, I mean, there's lots of climate conspiracy stuff, of course, as well.
Yeah.
Those would be the two main things. There are also people who have weird hypotheses that they just glom onto. One that's gotten quite a bit of traction is that there was some sort of comet or asteroid impact at the very end of the Ice Age. And this has very little basis in any hard, peer-reviewed science, but it's gotten weirdly embedded in some social media stuff.
Where'd that one come from?
Yeah, it's a weird. It has a long
backstory.
I don't know why, and it's not really affiliated with political points of view, but it's just grabbed people's minds, and it now has sort of got this life of its own. And students sometimes ask me about it because they've heard about it. So yeah, but the main ones would be creationism and climate denial.
I was thinking of, this rock does this, and the properties, the healing properties of every crystal and all that kind of stuff. We talked a little bit about that with our last guest because
yeah. I mean, one example
it's driven the price of rocks up. I mean, that's the one thing right there.
If it gets people valuing crystals, I think it's kind of harmless. But I mean, this is an old idea that goes way back to classical times. So, for example, amethyst. Everybody knows amethyst. It's the beautiful purple quartz. The word means it's amethos, which means not drunken. And supposedly, the Greeks thought that if you kept a crystal of amethyst in your pocket, you could drink unlimited amounts of wine. Maybe it came because of its color.
I sense an experiment.
And to me, it's like, okay, we could do a little empirical test.
That's a field trip in and of itself.
Yes, we could test this.
Go out drinking with amethyst in your pocket, drink with no amethyst, and see, is there any difference?
Why is this class only 21 and over?
But the crystal worship stuff, to me, that doesn't bother me. It means that people are revering these objects, and it's fairly harmless. It works for you, great.
I sense that there's going to be this turnaround with that buying crystals for these wellness things, and just like we're going to see with all these stainless steel tumblers, and we're going to see a glut entering Goodwill in the future. We're going to have Yetis and crystals and other things, and that's where I'm going to cash in and grab all the good stuff.
Yeah, it's the ones that are really chopping away at the foundations of science that are scarier. Right.
So I always think about this billboard question that I've heard asked a couple times. If you could be in charge of a billboard campaign, let's say, up and down major highway, you get to have your billboard. What do you want on that billboard? I guess for this cause, maybe there'd be other ones, but for this, when it comes to the teaching of
billboards,
the teaching of or learning of, what would that be?
Yeah, well, maybe something that would remind people that any thought of going to Mars, say, is completely ridiculous. To maybe juxtapose beautiful, verdant Earth picture with the bleak minus 150 degree polar desert of Mars. That's one thing that does, I guess this is going back to pseudoscience stuff. People seriously talking about colonizing or terraforming Mars as this is good planning. This is plan B in case we really wreck this planet or something happens to Earth. It's completely absurd and diluted, and I think dangerous, because it kind of demeans the Earth's truly unique habits, including plate tectonics, hydrologic cycle, carbon cycle, all the biogeochemical cycles that keep this planet habitable. People who think we could colonize Mars are just ignorantly dismissing those things.
Yeah.
The plans are, okay, well, there's water, we could melt the ice caps, and we could get some CO2 in the atmosphere. Well, how do you cycle that? How do you kickstart all of these things that have to continue to happen in over long time scales? It's so incredibly ignorant. It just drives me crazy.
I mean, true confession here. When I see those Mars stories or space stories or anything about that, or going back to the moon, I'm interested. I don't know if it's the whole some of it is the tech involved and just the story of the journey and all of that I think I find intriguing, that we could accomplish that or do that. Do we not have that in studying do we have that kind of same experience? We're like, check this out. Look what they're doing right here on Earth, though.
Well, we should. I mean, I'm a planetary geology geek too. I'm fascinated by the data sets that have come back from Mars over the last 15 or 20 years. I'm actually teaching a class about Mars right now. And we're looking at all of there's actually a seismometer on Mars, and we have better, higher resolution images of the whole surface of Mars than we do of Earth. It's kind of amazing. And you can zoom in online into these data sets. And
wait, it's really better than Earth?
It is, because we have this pesky thing called ocean.
Oh. Okay.
Yeah. So we know the entire surface of Mars is known at higher resolution than the ocean floor.
Okay. Yeah, that makes sense. Okay.
I agree. I mean, it's fascinating, but what we're learning is these are not places that we would be happy, and we can send robots, and the technology is fascinating. I think the little rovers that have been sent over the last 15, 20 years, starting with Pathfinder, Curiosity, Opportunity, Perseverance, they've sent back amazing stuff. They move slowly. But they've done field geology. They've sent back images, and we're, now the Mars Return Sample mission has been postponed.
Yeah.
But we can do so much with so much less money, sending robots and devices and satellite orbiters. The whole idea that we could ever establish anything like a viable colony on Mars, I think, is just wrong to promulgate, because maybe we could do it, but at tremendous cost. For what scientific payback?
Yeah.
Nah.
I was in Arizona in November, and we basically drove south all the way north into Utah. And this conversation came up on the drive, because there are places on that drive where you're not getting anything. And, when I stopped, I'm like, do we have a spare tire? Like, oh God, does this car not have a spare tire? It's got one of those like can inflators, and you're starting that you don't have cell signal. You still get radio. And you have all of that. And at that time I was out there and I was like, yeah, like try to get water out here. Try to get electrical out here. We've been living here for how long? And I was like, if you want to play, can we live here? There's places on the earth where you can play that right now, and do that. So why? Yeah, I agree with you. Like, why take the challenge to go to Mars other than can we do it? Space travel. But I mean, I feel like somehow I want both, I guess, is what I want.
Yeah, and again, I understand the coolness of space, but it's often because people don't really understand what's out there. I mean, it's not friendly. And it does irk me a little bit that people don't see the Earth as equally strange and mysterious. there's a lot of weird stuff that happened on Earth. And again, it's just people haven't seen it couched in that way. I think one of the biggest things we're learning as we look out in space, in our own solar system and then beyond to the now 7,000 or so exoplanets that we've at least detected. We can't see their surfaces. But we know that, in the census of exoplanets we know of, Earth-sized rocky planets are really unusual.
Yeah.
And certainly in the solar system, Earth habits of, again, an active water cycle, carbon cycle, life, and plate tectonics are not seen anywhere else. And so we're learning how really bizarre the Earth is and realizing all of these things are wrapped up in its habitability and its long-term hospitability. It's not just that it started out with the right ingredients. It maintained habits over the long term that have made life able to persist for at least 3.5 billion years. That's weird.
And what you're suggesting is we're taking it for granted to such an extent
we
that
are. Yeah. The thinking we could
we're like discarding it. Oh, we'll just go to another planet.
It reminds me when you talk to someone, like, let's say you visit a state or you visit a city, big city, and you're like, oh, we're going to go to this and this and this. And you're talking to someone that lives there and they're like, yeah, I've never been to any of those places. Like they, it's too close to them. So they want to go where you are and you want to go where they are,
Yeah. It's like kind of, dismissing what's right at hand. But one other thing I was going to say about Mars is people think that rocks and minerals just are, but in fact, they're made by processes. And when we look at Mars and the moon, probably Venus, although we don't have as much information, they're really kind of limited in the rock types. So the moon basically has 2 rock types. Yeah. Mars is basically all basalt, maybe with some sedimentary rocks that have been made by basalt sand. Earth has, all these different rock types, all these different mineral types that reflect the presence of water and life, and just so many ways of combining and recombining the same primordial ingredients in new ways. And these people, again, who think we could colonize Mars, I read a paper or something online recently. Somebody said, well, we can get aluminum out of the basalt. And it's like, okay, it's true. There's a lot of aluminum in basalt, but we don't get aluminum out of basalt on Earth. That would be crazy. It's so energy intensive to smelt raw igneous rocks. We wait for weathering to weather rocks deeply in places like Brazil and Jamaica, and then we send that ore to places like Iceland where they have a lot of free energy, and it's still energy intensive to smelt the aluminum out of even very deeply weathered rocks. Just like
we haven't even thought about the Martian tariffs on aluminum and basalt either.
Yeah.
The best source of aluminum is in the bin.
Yeah, exactly. Anyway, just, things like that, the very naive understanding of where all these commodities that we really take for granted on Earth are actually coming from. They are not going to be amenities that are available on Mars.
Well, lots to think about. I'm eager to read the book, and we're going to go back to this here. Of course, that's why we were kind of talking in the first place. But the book is Turning to Stone, and it does inject quite a lot of your own personal history into thinking about geosciences in a different way. And what's next?
Well, I do still have this day job as professor. I've got the seed of a new book in mind, but it's probably going to be a couple years out. So
it sounds like you're enjoying the writing phase, though, right now.
I am. It's interesting. I mean, I'm still writing scientific papers and things, and then this sort of writing is a completely different voice, and it's very freeing. I mean, when we write science for other scientists, there's really no room for metaphor. We have to be precise in the way we use language. But when I'm writing for more general audiences, it's critical. They're not going to stick with the writing unless it's evocative and paints some kind of imagery in their mind. So it's nice to have kind of both. I mean, there's room for all kinds of informal education to go hand in hand with classroom education. So that's what I see my role.
Well, very good.
We appreciate it.
Well, thank you so much for joining us, Marcia.
It was my pleasure.
This was great. Thanks for listening to our show. If you'd like to know more about this episode or any of our previous episodes, visit laboutloud.com. Lab Out Loud is produced by me, Dale Basler, and my co-host, Brian Bartell. If you have questions, comments, or suggestions for Lab Out Loud, visit laboutloud.com/contacts. Thanks again.